And now I'm going to explain another example. First of all, we have already known that Fn equals to Gn plus Hn. Gn is the cost of the cheapest path from node n to a goal state. Hn is the cost of the cheapest path from the initial state to node n. And using this formula, we will calculate the cost of the path. And I took a very simple example. Let's say this is the graph given to us, where S is the source node and G is the goal node. And here A, B, C, D, E, F are the intermediate nodes in this case. Let's start. The distance between S and A is 3. Similarly, the distance between S and D is 4. These are all the distances between these nodes here. And you see 11.5 is the heuristic value of S. The meaning of this one is the distance from S to G is 11.5. Similarly, let's say we have 5.8 on top of the B. The meaning of this one is the distance between B from B to G is 5.8, and so on. So for every node we have a heuristic value, and as well as between a pair of nodes we have distances here. Using this thing, we have to find the path which will give us the minimum cost here, starting from S to G. So I will start with initial node, S. I will write here. And you see, we have two neighbors here, A and D. So I will write here. Alright. What's the cost from S to A? This is 3, yeah? And G of A is nothing, but what's the heuristic of H of A? It's 10.5 in this case. So, like this formula, we have to write 3 plus 10.1, which gives us 13.1. And similarly, the distances between S and D is 4 plus the heuristic value of D is 9.2. So it gives us 13.2. So we have to choose the minimum cost. We have 13.1 and 13.2. Which one is the minimum? This one. Then we will continue with A, and S is visited. So A has two neighbors, B and D. So I will write here B and D. Okay, and what's the distances between S and B? This is 3 plus 4, yes? So I will write here 3 plus 4 plus, what's the heuristic value of B? It's 5.8. So I will write here, it equals to 12.8. And let's look at D. The distances between S to D, this one, 3 plus 5. So I will write here 3 plus 5 plus, what's the heuristic value of D? 9.2. So, which gives us 17.2. Alright, so we have this one, and this one. Which one is the minimum? Of course, 12.8. So we will continue with B. And what is the neighbors of B? C and E, yes? That's why we write here C and E. Alright. And what's the distances between S to C? Look at this one. 3, 4, and 4. So 3 plus 4 plus 4 plus, what's the heuristic value of C? It's 3.4. So plus 3.4, which gives us 14.4. And let's look at E. What's the distances between S and E? This one. S, A, B, B, E. So we have to look at this one, this road. 3, 4, and 5. So I will write here 3 plus 4 plus 5 plus, what's the heuristic value of E? 7.1, which gives us 19.1. So we have this one, this one, this one, and this one. Which one is the minimum? Of course, D, yes? Then we will continue with D. And let's look at the neighbors of the D. D has two neighbors here, A and E. So I will write here A and E. Okay, let's look at A. So the distances between S and A is this one, yes? S, D, and E. So 4 plus 5 plus 10.1, which gives us 19.1. And let's look at E. From S to E. 4 plus 2 plus, what's the heuristic value of E? 7.1 plus 7.1, which gives us 13.1. And so we have 14.4, 19.1, 17.2, 13.1, and again 19.1. Which one is the minimum? Of course, 13.1, yes? So we will continue with E. So which one is the neighbors of the E? B and F. So I will write here B and F. And let's calculate the distances. So from S to B, what's the distances? This one. Look at this graph. S to B. S, D, E, and B. This one, yes? 4, 2, and 5. We have to write 4 plus 2 plus 5 plus, what's the heuristic value of B? 5.8 plus 5.8, which gives us 16.8. And let's look at F. SDEF road. SDEF. 4, 2, 4. So I will write here 4 plus 2 plus 4 plus, what's the heuristic value of E? 3.5, which gives us 13.5. Yes? Okay. And we have again 14.4, 19.1, 17.2, 16.8, 19.1 and 13.5. Which one is the minimum? Of course this one, yes. So we will continue with F. And F has one neighbors. It's G. So I must write here G. And as you see, G is our goal node. So I will stop here because this is the goal. So to go from S to G, the path to reach G from S is this road, yes? S to D, D to E, and E to F, F to G. So the answer will be S, D, E, F, and G. Minimum cost here, what will give us? S, D, E, F, G. 4 plus 2 plus 4 plus 3.5, which gives us 13.5. The minimum cost is 13.5. So in this video, we have discussed what is a star search algorithm, how can we apply a star search algorithm to a given problem so that we can go from initial state to goal state. If you liked the video, do like and share with your friends. Thank you for watching.